Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, subscribers, viewers, and students. Here is another video in Engineers in Progress, particularly on the topic on equations of the locus, which is part of analytic geometry. Allow me to present the solution in a manner that is with less animation so that I can discuss these four problems in just a considerable number of minutes. So here we go. Find the equation of the set of all points equally distant from the y-axis and 4, 0. So this is problem 44. So we have to draw the figure. We have the coordinate axis. By the way, this is problem 45. And let's focus first on problem 44. So we have here a given fixed point, which is 4, 0, and the y-axis, the equation of the y-axis is x equals 0. And we have to find the equation of the set of all points equally distant from this point 4, 0 and the y-axis, which is expected if you are already expert in analytic geometry. The expected locus is the locus which is a parabola. So let's draw the figure. This may be the locus and this is the point. So the distance of this point, the point is of course denoted with x, y, and the distance of this point from the y-axis, that distance, because this is x, y, the distance of this point from the y-axis is x, so distance 1 is x, and distance 2 is distance between 2 points, distance formula. So that is d sub 1 equals d sub 2. So d sub 1 square equals d sub 2 square. So since d sub 1 is just x, so x square equals, so distance between x, y, and 4, 0 by distance formula and by Pythagoras theorem is quantity x minus 4 square plus quantity y minus 0 square. Expanding, so we have x square equals x square minus 8x plus 16. So negative 8x is twice the product of x and negative 4, and positive 16 is negative 4 squared. So that's algebra already. You're already in analytic geometry. So you should be able to understand the expansion. So plus y square. We can cancel x squared, so simplifying, we have y squared minus 8x plus 16 equals 0, so which is a parabola indeed. Then, based on the figure, this point, which is 2, 0, should be a point on the locus, so that its distance, the distance of 2, 0 from the y-axis is 2 units, and the distance of 2, 0 from 4, 0 is also 2 units. So 2, 0 must satisfy the equation of this locus. So 0 squared minus 8 times 2, so negative 16 plus 16 equals 0. So we are confident that this is the equation of the locus. Problem 45, what is the locus of a point which is at a distance of 4 units length from 5, negative 2. So this locus is a circle because the distance is 4 units, and thus as the point moves, its distance from this fixed point, which is imagined or considered as the center of the circle is constant, and that constant distance is the radius supposedly. So that's 5 comma negative 2, and this is the point which is designated by x comma y. So therefore, the parts of this right triangle are right x, which is x, minus left x, 5. So this is x minus 5, while the vertical leg is y minus negative 2. So y minus negative 2 is y plus 2, and that's the hypotenuse, which is the distance between the moving point and this fixed point. So by Pythagoras theorem, quantity x minus 5 square plus y plus 2 square equals 4 square. So expanding, so distance square is also 4 square, this distance here. So x square minus 10x plus 25 plus y square plus 4y plus 4 equals 16. So we simplify the equation. So 25 plus 4 is 29 minus 16 is 13. So therefore the equation of the locus is x square plus y square minus 10x plus 4y plus 13 equals 0. So that is x squared plus y squared minus 10x plus 4y plus 13 equals 0. So that's it for this problem, and take note that if you're expert in analgebra, this represents equation of a circle because the coefficients of the second degree terms are equal. Problem 46. Find the locus of the center of the moving circle tangent to the y-axis and to a circle of radius 2 units with center at 8, 2. So to help analyze the situation, let's have the figure. And this is the fixed circle with center at 8, 2. The radius is 2 units. And we have a moving circle which is always tangent to this fixed circle here and the y-axis as shown. These are just representative circles. So let's go focus on this circle here, colored green. This is the center of that circle because it is tangent. So if the coordinates of the center of this moving and growing circle is x comma y, and since it is tangent to the y-axis, its distance from the y-axis is x, and because it is tangent to the y-axis, that is also the radius, the variable radius of this moving circle. So as it follows the law, which is to be always tangent to this fixed circle of radius 2 and center at 8, 2 and the y-axis. So that's x. This is also x, which is the radius of this moving and growing circle, and that is 2 units. Therefore, the distance of the moving point x, y and 8, 2 is x plus 2, and this is the locus. So by Pythagoras theorem, so this is y, the vertical leg of this imaginary right triangle is y minus 2, upper y minus lower y, and the horizontal distance is x minus 8 or 8 minus x, it doesn't matter. So the hypotenuse is x plus 2. So that's why by Pythagoras theorem, quantity x minus 8 square plus y minus 2 quantity square is equal to quantity x plus 2 square. Expanding, we have x square minus 16x plus 64 plus y square minus 4y plus 4 equals x square plus 4x plus 4. So cancelling out x square and 4, and simplifying, we have y square minus, so we have negative 16x minus 4x, so minus 20x, then minus 4y then plus 64 equals 0. So that's the equation of the locus. So to check our answer, there is a circle here which is with center aligned to 8, 2, and since this is 2 units, so that means the diameter of the circle with center aligned with 8, 2 would be 6. The radius is 3. Therefore, the coordinates of that point, which is supposedly the vertex of this locus, which is a parabola, is at 3, 2. So if 3, 2 is substituted into this equation, so we have 2 square, which is 4 minus 20 times 3, so negative 56 minus 4 times 2, negative 56 minus 4 times 2, negative 64, and negative 64 plus 64 equals 0. So you should be confident that this is the answer. And lastly, for this video, problem 47, find the equation of the locus of the third vertex of a triangle if the base is at negative 2, negative 1 and 3, 2, and the area is always 7 square units. So to help analyze the situation, let's have the plotting of points negative 2, negative 1 to 3, 2. There are two possible loci. One is the moving point is above this base and the moving point is below that base. Let's focus first on this point here, which is above the base, and that's the expected locus. So by area of polygons by coordinates, so area, which is 7, is equal to 1/2. And remember, the point should be arranged in counterclockwise direction to make the area positive. So x comma y, first point, then negative 2 negative 1, then 3 2, then back to the initial point, which is x comma y. So 7 times 2 is 14, and it is equal to negative x, then plus negative 4, then plus 3y, which is that, then minus quantity, negative 2y, negative 3, and positive 2x. Expanding and simplifying, so 14 equals negative x minus 4 plus 3y plus 2y, minus of negative 3 is plus 3, and minus of 2x is negative 2x. Combining like terms and simplifying, we have negative x, negative 2x. To the left is 3x, 3y plus 2y is 5y. To the left, minus 5y, and negative 4 plus 3 is negative 1. Negative 1 minus 14 is negative 15. So the first locus, which is represented by this line here, is 3x minus 5y equals negative 15. For the second locus, which is this, so this is x comma y, so 7, again the area is 1/2 of beginning with this point in counterclockwise direction. So x comma y, then 3 2, then negative 2 negative 1, then back to x comma y. So 7 times 2 is 14 equals 2x minus 3, then minus 2y, minus quantity 3y, minus 4, minus x. So expanding and simplifying, 2x minus 14 equals 2x minus 3 minus 2y, then negative 3y plus 4 plus x. Combining like terms, 2x plus x is 3x, negative 2y minus 3y is negative 5y, and 14 plus 3 is 17, 17 minus 4 is 13. So the second locus is 3x minus 5y equals 13. So that's it for this video. I hope that you were satisfied with my solutions and explanations, and I hope that you were able to follow the solutions. And I also hope that you can solve problems by your own about equations of the locus.